Hey everybody, welcome to finding limits of a function graphically. So there's a few ways we can look at finding limits of a function graphically, and one way is to use a table of values. Okay, so we've already looked at the limit introduction video, and so we kind of know the notation of how to write a limit, left and right hand limits. Okay, so there's some things that we're going to look at, but let's look at this example. Okay, and what we're going to do is we're going to find the limit of this function, okay, f of x, and f of x is equaling this blue function right here, and it's drawn here for us nicely, and consider the limit of the function as x approaches 2. So we want to know what happens when x approaches 2. So what you need to do is when we look at the 2 value here, and I draw a little circle here, I always have to look at, well, what's going on to the right of that number as we go along the function and from the left. And it appears our function is going to have a limit as x approaches 1. So bottom here, as x approaches 2 from the left and the right, what happens to the function? What happens to the value of f of x? The value of f of x, so f of x approaches 1. Okay? F of x is approaching 1. Okay? And that I have to make a major statement here. It's approaching 1. I didn't say it equals 1. I said f of x is approaching 1, and that is a huge thing for us. It's approaching 1. Okay, so how do you do this from a table of values? So here's what you need to do. On your TI-84, you're going to hit y equals. Okay, so we're going to go y equals, and you're going to type in your function. You're going to put in x squared minus 2x plus 1. Okay, and then I'm going to hit enter, and then I'm going to quit. I'm going to hit second mode. Okay. I need to do 5 decimal places, I think it says. Yep, 5 decimal places, which in calculus you only need 3 decimal places. Okay? And we need to plug in, and we're looking for values from the left and from the right. Okay? And so notice how all these values are really independent. They're really specific. So I'm going to be able to enter those in my calculator. I'm going to hit second, and I'm going to go to window, and I'm going to hit second, and I get that blue value, the table set. Let's cursor down and go to ask. Okay? And then I'm going to hit second mode again, second quit, and then I'm going to go to my table. I want that blue table, so I hit second graph. It's blank. And now I can start plugging in all these numbers. And I'm going to plug in a couple, and then I'm going to pause. I can plug in 1, and I get 0. Okay, so if you look here, when you plug in 1 to the function, look, you get 0. Yes, you do. If I plug in 1.5, okay, is a quarter. Now, unfortunately, I still haven't put this to 5 decimal places. If you wanted to, you go to mode, and you see float. You go down to float and cursor over to 5 and hit enter. So I apologize. I'm going to go ahead and go back to my table. It should update. Yep. Okay, I'm not going to have space for all this. I'm going to plug in 1.9. Okay, and then what I'm going to do here is I'm going to pause and allow you to plug in the rest of these values on your own. Okay, and when you come back, these are all going to be filled in. Okay, so hold on 1 second. So go ahead and try them, and then you can check your answers with mine. Okay, so notice how we picked numbers that were really close to, getting really close to 2 from the left and really close to 2 from the right. And you can see that they're very close to 1. Okay. So as we continue on, here's that limit notation definition. So the limit as x approaches your number of your function is equal to L, where L is a number. So if I was going to rewrite that limit, okay, definition with our function, I would say the limit, okay, as x is approaching 2 of f of x. F of x is equal to x squared minus 2x plus 1. And that equaled 1. So there's the answer to that. Now here is where from the first video it said, hey, look to Mr. Bennett to show you that a limit is not the function value. It's just the number that you're approaching. So if you read this, at this point you may wonder, why don't we just always plug in, why don't we just plug in the value at x equals 2? It works. It's a polynomial. That's a polynomial. It's defined there. Okay. it turns out, so the limit doesn't care about what happens at x equals 2. It only cares about what happens as x approaches 2. So this last part right here is a beautiful example of that, okay? It's the same graph drawn so the graphs of 3 different functions are shown, okay? But let's face it, they're 3 different functions, but it's the same parabola, okay? And so in this one, it's saying, hey, on the left, f of x, what's the limit as we approach 2? So each one of these we're approaching 2. And notice how this one is nice and filled in. And so this is going to be 1, because from the right, okay, and the left, we're approaching 1. Notice in g of x here, in the middle graph, we're still approaching 2, the limit of x approaching 2 of g of x, but there's a hole here. G of x, g of 1, or excuse me, g of 2 does not exist. It doesn't exist there, but who cares? We're not asking about the function value, we want the limit. The limit, we're getting really, really close to 1. H of x here, and notice how it still has a hole there. But the difference is from g of x is that the function's actually defined there. So the limit as x approaches 2 of h of x is also 1, okay? But there's the function value right there, okay? So the function value doesn't have to equal the limit. The limit is just what number are you approaching. It doesn't have to equal the function value at that point, okay? So if you have any questions or comments on that, please let me know. We're going to stop this video and we're going to go on to video number 2 here, okay?